So, test one review answers for Thursday, September 6th, 2018. We will go over these on Monday as well, for those of you that are watching it on the Monday, Wednesday class. Empirical rule. What does it tell us? It tells us that 68% of data will be within one standard deviation. It's approximately, right? It's not exactly 68%, but it's pretty close. It tells us that 95% of data will be within two standard deviations. It tells us that 99.7% will be within three standard deviations. Now, what does it tell us for four standard deviations? A lot of people will assume that if 3 is 99.7, that 4 must be like 100 or something like that. That is not true. In fact, the empirical rule doesn't tell us anything about four standard deviations. So what does the empirical rule tell us will be within four standard deviations? It's undefined. It doesn't talk about it. And it don't talk about 5 either. Okay? So you would just write undefined for both D and E in that case. As we move on and we look at Chebyshev's theorem, according to Chebyshev's theorem, at least what percent of the data is expected to be within certain standard deviations? Chebyshev's theorem is undefined at one standard deviation, so it doesn't work for this one. Okay? For two standard deviations, you would do 1 minus 1 over 2 squared, which is 75%. So at least 75% of the data is within 2. For 3 standard deviations, you would do 1 minus 1 over 3 squared, which is 89%. For 4 standard deviations, you would do 1 minus 1 over 4 squared, and you get, I think it's 93.75%. We'll go to the calculator and verify that out. It's 1 minus 1 over 4 squared. It is 93.75%. And with that, 93.75%, 93.75%. What percentage is within 5? 1 minus 1 over 5 squared, which is 1 over 25, 24 over 25, 96%. 96, shucks. 96%. Okay. Which one of the two works with any data? That would be Chebyshev's theorem. Empirical rule only works with bell-shaped. Okay. Pretty much straight off of question 2, what are the differences and similarities? There's another whole video for that. I can't link that video, but if you go to YouTube, type in my name, type in ER versus CT, you will get the empirical rule in Chebyshev's theorem. Okay. Now, as we move over to look at the number of movies that people saw using MoviePass, we have this data. We will type that into our calculator. We will use stat edit. We will type those numbers in. We will type in 8, 12, 14, 9, 11, 6, 0, 2, 11, 10, 15, 12, 13, 7, and 11. All right. General rule of thumb is if you click on the last number you put in, that number there is the number of values you've inputted. I've inputted 15. It's always just a good reference to go back and double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Verify that you have 15 numbers, that you've typed in 15 numbers, and then assuming that you haven't made a mistake typing them in, you'll be able to get most all these values. So we got stat, calc, one variable statistics. We press enter. Again, for those of you that are using the more the TI-84s, you may get to a place where you have to press enter a couple times through a couple of the little wizard screens, frequency list and all that. Just keep pressing enter. Get to the bottom where it says calculate and go ahead and hit enter on that. For the mean, it's 9.4. So if we're going to interpret that, let me see if I cannot take a screenshot. Stupid damn thing. The mean is 9.4, so what we would say there is average number of movies saw by the MoviePass subscribers was 9.4 movies over the summer. Find and interpret the median. If we go down, we see the median is 11. So the median in this case is 11. How do we interpret that? 50% of the people saw less than 11 movies and 50% saw more than 11 movies. The mode, what value occurs the most often? It looks like that number would be 11. It looks like 12 shows up twice, 11 shows up 3 times. So in this case, the mode is 11. The number of movies that were gone to this summer that occurred most frequently was 11. Find and interpret the standard deviation. The standard deviation is on the calculator. It is SX. SX is 4.2. So the standard deviation is 4.2. That is the average amount of deviation each person had from the mean. So we would say on average, the number of movies that people went to deviated by 4.2 from the mean. Find the variance. The variance would be 4.2 squared. This is not one I would ask you to. This is not one that I would ask you to do on your own or to interpret. You would just have to find it if you were asked to. It is 4.2 times 4.2, which is 17.64. Okay. Now again, I'm kind of running through these relatively quickly. Feel free to pause them, do them on your own. Probably a little late for that. Go back, hit rewind. Finishing this off, we've got find and interpret P19. This is P19 for those of you that are trying to read this at home. P19. How do you do that? You do 0.19 times 15. You do 0.19 times 15. And if you remember, this is what I said with the Publix rule. You take this and you always round up. Any decimal you get here will round up. That's the third spot. Okay, that's the third place in the data set. Now, just if it happened out that you did 0.2 times 15 so that you got 3, then there's nothing to round up. It's 3. So the way you would do this is you would do the average of the third and fourth values. You would add them together and divide by 2. That would be the way you would do it if it landed exactly on a number. If it doesn't land on a number, which is kind of preferred actually, you would just round that number up and then go find it in the data set. Now, I got to find the third value in the data set. What I'm going to do is cheat. I'm going to go to Stat. I'm going to go to Sort A. I'm going to sort that list. Whoa, not like that, I'm not. I'm going to sort that list. That's going to take those numbers and put them in order. And now, when I want to find the third spot, I'll just count 3 places into it, and the third spot is 6. So P19 would be 6, which says that 19% of the movie people saw less than 6 movies. Okay. Find and interpret Q1. Q1 is found on the calculator. That was one of the options that we had when we were here and we went to one variable statistics. Q1 and Q3 both show up here, so Q1 is 7, Q3 is 12. 25% of the MoviePass subscribers went to 7 movies or less. 75% went to 12 movies or less. If you just said less than 7, that's fine. If you said less than 12, it's fine too. Find and interpret the rank of 10. The rank of 10 is the percentage of values that are less than 10. It is the percentage of values less than 10. How many numbers are less than 10? 1, 2, 3, 4, 5, 6. There are 6 numbers less than 10. You'll notice that we don't use 7. We're not including 10. It is strictly the numbers less than 10 and there are 6 of them. So in that case, find and interpret the rank of 10, it would be 6 out of 15. Doing that math quickly in my head would be 40%. All right. And so what would we say there? 40% of the subscribers went to, when they went to, 40% of the people went to see fewer than 10 movies. Okay. Find and interpret the z-score that corresponds to 15 movies. The way you do that, again, you're back out, finding the mean and the standard deviation and all that. We got the mean is 9.4. We got the standard deviation is 4.2. So to do the z-score 15, it is 15 minus 9.4 divided by 4.2. This is the mean. This is the standard deviation. 15 minus 9.4 divided by 4.2. If you type that in, if you're going to do it all at once, you got to use parentheses. If not, you would do it, press enter, and then hit divide. 15 minus 9.4 divided by 4.2. You get 1.33. What I was saying the other way was, if you don't want to use parentheses, you'd have to do 15 minus 9.4. Just get that answer, and then divide that by the 4.2, and that would be the other way to do it. Either way, you get 1.33. Okay, and what does that mean? Somebody who saw 15 movies over the summer was 1.33 standard deviations above the mean. Okay, looking at the above data, which one represents sigma? Well, what is sigma? All right, sigma, some of you say sigma means sum. It does mean sum, but that, let me remind you, is capital sigma. That means sum. This is lowercase sigma, and lowercase sigma means population standard deviation. Okay? Now, some people will go like this. Well, which one of those represents it? And you're thinking to yourself, I don't need to represent it because my calculator told me what it was. That's not what we're talking about here. All right? We're not talking about which one is closest to 4.07 or anything else. What we're saying is, of all these values, from A through J, which one best represents sigma? If sigma is the population standard deviation, then the sample standard deviation would be your best approximation for that. And so for that, you would just say the sample standard deviation. Okay, and if I knew what letter that was, I believe it was letter D. I could just say it's letter D. Okay, sample standard deviation, letter D. Okay. So with that being said, that's the answers to the review sheet. If you have any questions, feel free to email them to me at sdryer@polk.edu. For those of you that have iMessage, that would be Stephen with the PH, stephen.dryer@gmail.com for iMessage. For those of you that with Androids, turn it in. Have a great day. Be blessed.